Okay, so in this video we are going to look at friction again, and we call it friction 4. Okay, we want to look at energy concepts in terms of friction. In this question, we believe that there is a body here released at rest. Okay, so it has 3 energy: work done due to friction, and then kinetic energy, and then potential energy, which is work done due to gravity. So in the absence of frictional force, total work done is delta K, which is change in kinetic energy, plus change in potential energy, which is equal to 0. This is in the absence of friction. Absence of friction. In the presence of friction, we have delta K plus delta U, which is equal to negative, which is equal to work done by friction. This is in the presence of frictional force. So in this question, or in this video, we want to deal with one with friction, not this. So we are not going to talk about this, but we only talk about this. All right? What is change in kinetic energy? That is K2 minus K1. What is change in potential energy? That is potential energy 2 minus potential energy 1. And that will be equal to work done due to friction. So, and that will be minus FL. That is length of the path taken. All right? So, if this is the case, what is the reason for putting negative sign here? The major reason is that, of course, the body is coming this direction, while frictional force is always this direction. So the frictional force is opposing the force that is bringing down the body. Therefore, it has to be in negative sign. All right. What is K2? K2 is half mv square, and K1 is half mu square plus potential energy 2. Potential energy 2 is here when the body is here, and that will be mgy2 minus mgy1 is equal to negative fl. All right. Now, half mv square, that is kinetic energy when the body reaches here. Half mu square, that is kinetic energy when the body is released. mgy2, that is potential energy when the body reaches here. mgy1, that is potential energy when the body is here. All right. So we take half mv square minus the initial velocity here is 0 since the body is released. Take note of the word released or dropped. Anytime released or dropped is used, the body is released or dropped, then initial velocity will be 0. So everything here will be 0. Plus mgy2, that is the potential energy when the body is here, and of course the height y2 will be 0 here. When you trace it here, it will be what? 0. And everything here will be 0. Minus mgy1. y1 is here. When you trace it like this, it is h. So we change it to h, and that is minus fl. All right. So what do I have left? I have half mv square minus 0 plus 0, that is 0, nothing, then minus mgh is equal to minus fl. Let's multiply by 2. We have mv square minus 2 mgh is equal to minus 2 FL. All right. So from here now, what do we have? What do we have from there? We have mv square is equal to 2mgh minus 2fl, and we have, of course, we can divide all through by m. So we have v square is equal to 2mgh minus 2fl over m over m. So v square is equal to 2 is common, m is common, 2 over m, open bracket, mgh minus fl. So the v now, v here will be square root 2 over m, open bracket, mgh minus fl. Good. Now we can play with numbers. Let our L equals to maybe 100 meter, and let the mass be 1 kg, and let height be 10 meter. So if you are asked to find the final velocity when the body is released from here and move down to this point, then this is the formula to use, and you have 2 over 1, open bracket, 1 times 10 times, what do we have here? 100. What is my h? My h is 10. So we have 10 minus, okay, let my f be 0.5. So I have 0.5 times, what is L? 100. 100, and I have this, then all in square root. What do I have? Square root 2, open bracket, 100 minus 50. So I have square root 100 minus 50, that is 50. 50 times 2, that is 100, and that will give me 10 meter per seconds. So in this video now, what we are just trying to do is that take note of any frictional question that comes in this way. The body is released and the final velocity is given by this formula. Let us just take a look again. What is mass? 1, correct. Mass is 1, g is 10, h is 10 according to what is given here, and my frictional force is 0.5. So as a result of that, I have times L, which is 100 meter. So from there I have 200 minus 50, I have 100, so which is going to give me 10 meter per second. However, before I stop, when the body is dropped, this is the correct formula. But when the body is moving from here to the top, the correct formula will then be U, because our final velocity must have been 0. If the body is being pushed from here to the top, then my U is equal to square root 2 over m, open bracket, mgh plus fl. The difference is just the sign, minus, and here we have plus. So thank you for watching this video. Please watch the video, like the video, and then subscribe. Thank you so much for watching.